So depending on what research question you chose and the type of data that you're going to collect, you may have quantitative data, which kind of is it's going to be very similar to what we talked about yesterday, but it's also going to be a little bit different in term. Like we still have a p-value, but how we interpret that p-value is going to be a little bit different, and also some of the things that we're going to be looking at is going to be a little bit different as well. So remember, with quantitative data, this is where we looked at what shape of our data was on a histogram. We looked at the 5-number summary, the mean, median, and outliers. Some of that stuff we're going to do here as well. So in terms of that, and we're also don't organize our data in a two-way table with quantitative data. So the first thing we want to do, the process for analyzing quantitative data is similar in ways to categorical data, but it's also different because the data is numerical. So here's an example of like a quantitative data type of research question. Is there a significant difference between males and female run times in a 5K? So what would a null hypothesis be for this? Remember, a null assumes there is no difference between those. So we might say there is no difference in the average run times between males and females in a 5K race. This has nothing to do with what you actually think. This is the null hypothesis. So we're going to start by analyzing our data, by organizing our data, which means we want to sort our data into groups. And in this case, we're going to sort them between males and females, because that's what our data suggests. This is our, this is just a, just a generic example. You want to, I don't think that I've said this so far, but you need to have on these 30 of each group. So this one wouldn't classify. I only have 1, 2, 3, 4, 5, 6, 6 males and 6 females. So this would not classify as that, but I wanted to put this up there just so we can kind of have an example. But 30 wouldn't necessarily fit on this one page. And then we're going to use descriptive statistics, such as means, medians, standard deviations, outliers if we have them, and maximum and minimum values of each group. So we can do this in our calculators. We can use our 1var stats, or we can use Google Sheets, maybe even old Google Sheets that we use in Unit 9, where you had that practice page. It calculates means, medians, standard deviations, and outliers. And I think maximum and minimums if you want to use that as well. Actually, I don't think it does the standard deviations. That was only in our calculators that we did that. So here's just the descriptive statistics of that previous page that I just did. If I typed all this in, I would get the following information. There were no outliers. The following means, median. We can use 1 or 2 var stats for all, but outliers, you can use the Google Sheets from Unit 9 for the outliers. So this is, we don't organize our quantitative data into a two-way table because it's not count. We don't count them up. We list them out. So we separate them and we list them out. And then we want to create visuals. The visuals we use for categorical or quantitative data was a histogram, and we would compare if it's skewed left, skewed right, or symmetric, meaning normal. I do not have enough data to create a histogram for this one. It's not letting me on Google Sheets. So, but you would highlight your data, create a histogram as we did in Unit 9. And then describe the shape. And then now we're going to go to the calendar, and this time we're going to select on, I think it's Tuesday, for the independent t-test. This is the same type of test, but for quantitative data and not categorical. And we're going to type in our information as we see fit on there. The independent t-test is a statistical test for quantitative variables. And you compare the means of 2 different groups to see if they're significantly different from each other. This is found on the same template. I actually said it's found on the same template. I actually separated those. So here I say you can select the bottom of the page. Let me show you where that is. Not that. Let's see where that is. Not that. Oh, here it is. Okay, so the 31st, Monday, we had chi-squared right here. And Tuesday, we have the t-test. So we're going to click on t-test. This looks kind of similar, but also a little bit different. But the process is the same as we did. We're going to enter our males in variable 1 and our females in variable 2, or vice versa. And what you'll see is at the top in columns D and E over here, it automatically is going to calculate our mean, our standard deviation, and our sample size. And then we have this upper and lower bound, which we'll talk about here in a second. And then we have the p-value at the bottom like we did in the other one. So it will be right here, and then we're going to need to interpret that based off of what we have. Like, is p greater than 5 or less than 5%? I don't know if I have that on here or not, but we'll see. So the t-test, just like the chi-square test, indicates the probability of observing the data if the null hypothesis is true. It's essential that the certain assumptions are met for the results of this test to be valid. So for one, we need to try whatever we can to make our sample random. Independent observation. This means that the occurrence of one observation does not influence or affect the occurrence of another. And then also the population of each group is normally distributed, or the sample size of each group is at least 30. So we need to make sure that that happens. So in this case, males and females, run times of 5,000, 5K. We need to make sure that we have at least 30 for males and at least 30 for females. And then we're going to perform an independent t-test by typing in our data. So type in your data to the template, write down the p-value, and compare that to the significant value, which is 5%, and then write the interpretation. The interpretation is slightly different with quantitative data. Just like with categorical values, the p-value tells us whether there is enough evidence to reject the null hypothesis. If we do not have enough evidence to reject the null, then I would also consider constructing a confidence interval for the parameter of interest. So that's what we're going to talk about briefly. A confidence interval is the other thing that we see, the lower bounds and the upper bounds on the spreadsheet. And it basically gives us a range that contains the true population parameter, which is the difference in means with a certain level of confidence. And we state this is 95%. So you only need to do this when you reject the null. So if you reject the null, you're saying that I think that there is something there. I think that there is a correlation, and I'm 95% confident that correlation is between this and this in terms of the average or the means. So, suppose you are collecting heights of people in a certain city. You calculate a range, which is the confidence interval that likely contains the actual average height of the whole city. So you say, I'm 95% confident the average height is between 5.5 and 6 feet. It means that if you repeated your measurements many times, so 95 out of 100 times, the true average would fall within 5.5 to 6 feet. And that's kind of what that confident interval is saying. So interpret the p-value. On this particular test, when I ran this in, when I plugged in the data for this, I would say that there is a 55.9% chance of the null being true. So meaning there is no relationship. That's a pretty significant amount. So since 55.9% is greater than 5%, we would fail to reject the null, which means we accept the null, which also tells us that we think that everything is as it should. There is no relationship. We just use these weird double negative things as we're talking about statistical studies. There's not enough evidence to conclude that there is no effect or is in effect difference or relationship that is statistically significant. All right, let's look at your turn. So I'm going to have you guys try this. If you are watching this for the first time, use that template that I just showed you guys, plugged it in this information. So for your project, you and your partner decide to have a cookie bake-off to see who is the better baker. You both decide to make chocolate chip cookies and then have them randomly select 20 different students, blindfold them, and have them taste test both cookies. Cleansing your palates in between and then rating each one of them on a scale from 1 to 10. The results are shown below. So we want to determine the descriptive statistics, which is the mean, median, standard deviation, and max, and minimum of both, and then determine the p-value and interpret its meaning. So here is our results. Rate each cookie 1 through 10, with 1 being grossest and 10 being delicioso. So once we have those, we find the following. This is our descriptive statistics. When I put this in, I found that there was a 0% chance of the null being true, which states that there is no relationship between these. Since 0% is less than 5, we reject the null. We don't agree with it. So we do say that there is significant evidence. Therefore, the average difference for both cookies are not equal. We are 95% confident that the true average difference between cookie A and cookie B is between 1.83 and 4.17 scores for that average difference in means. And basically, this is, once again, kind of copying down what the template is saying. And that's all we have for today.